Okay, here we go. Unit 9, Skill 3. How do we write trig equations from word problems? That is something that we're going to have to be able to do. It shows up on the Regents all the time. So, example 1. A signal buoy in the Chesapeake Bay bobs up and down with a height h, transmitter above sea level. During a small squall, its height starts at 9 feet, but goes all the way down to 1 feet before going back up to 9 feet. So what you have to kind of be picturing is, hey, look, I got a height, something starting up here, it goes down, comes back up, goes down, comes back up. If there are 4 seconds from one 9-foot height to the next, determine the equation that will model the situation. First off, have you ever been in a boat that's gone from 9 feet all the way down to 1 feet? Oh my goodness, yeah, I did on Lake Ontario charter boat fishing first time. And let me tell you, I have never puked so much in my life. I was pukey pukerson. Man, it was bad. So I would not want anyone to have to do that. Although I had a lot of fun, I caught a lot of fish. I'd probably do it again, but I would not want to puke that much again. So anyways, the steps that you're going to take, right? Draw a sketch, modeling the midline, max, min, period, all right, as given. So you want to model it all, draw that sketch, figure out what it looks like, and then write your equation. It's far easier to come up with this once you have a sketch. All right, here's some steps for calculating the midline. Oftentimes you can just figure it out, but if you need some help, there it is, max, min divided by 2. All right, the amplitude usually is pretty straightforward to find the middle, but again, max minus min, and then you should be dividing by 2. Anyways, so put that in there, divide by 2. Calculate the frequency, and then write the equation. So we're going to jump right into this. Hopefully these won't take nearly as long as the last couple of videos that I did. They were 20 minutes, and I am sorry. So, what do we got going on here? The wrong graph. Need to have this guy down here. Alright, so the boat is going to be living in between 9 feet, or I'm sorry, not the boat, that was me. The buoy is going to be between 9 feet and 1 foot. So we got 9, we got 1. So that's our max and our min. And it's going to be going up and down and up and down. Now it starts at 9 feet, so we are starting up here, okay? Which means if we're starting all the way up at the max, this is going to be a cosine curve. A sine curve starts in the middle. All right, if you need to, maybe off to the side, draw yourself a sine curve. That is ugly. Draw yourself a cosine curve. That's not a whole lot better. So that you know what they kind of look like. All right, so it's supposed to end after 4 seconds. So I'm going to count, over to 4. That's where my 4 is going to be, and that's where it's going to end. I'm going to try and draw it. So in the middle, halfway, which is about here, it should be at its low point. Play connect the dots. Just try and get a basic sketch. Okay, so there is my sketch of this cosine curve, which kind of gives away that it's this guy. Cosine equation. All right, the middle. I need that midline, so we'll put that with red. So the midline's got to be right here in the middle. I need to find that. All right, the midline is very simply found by adding the max and the min and dividing by 2. Although you can look at 9 and 1 and say, hey, 5 is in the middle. Or if you need to, you can do 9 plus 1 and divide by 2 to get 5. I don't really care. Same thing for the amplitude. Now that you know you have 9 and 5, if you really want to, you can do 9 minus 1, right? It's max minus min, and then divide by 2, right? But I don't think you should need to. You can count from 5 to 9 and say, hey, that's 4 away. The amplitude is 4. So I have an amplitude of 4. I have a shift of up 5, right? I have a period of how long? How long did it take for one cycle? It said 4 seconds. There it is. So I have 4 seconds. And, well, I'm in pretty good shape now, right? So let's start writing the equation, see what we're missing. So I have y equals, or f of x, totally up to you. The amplitude comes first. We said it was a cosine curve. It's cosine simply because it starts above. All right. I have to put the b in front of the x. Oh, that stinks. That's the frequency. I don't have the frequency yet, do I? So, and then I have plus 5 because the whole thing is shifted up 5. So b is the frequency. It has to go in front of x, and that is found by doing 360 over the period or 2 pi over the period. Now, if the question doesn't say, I would totally always choose the easy one, right? So 360 is usually easier as far as I'm concerned. So the frequency, come on, start writing. The frequency is going to be 360 over the other guy, 4, which is 90, and we're good to go. So I'm going to put a 90 here. So I have an amplitude of 4. It's a cosine curve because it starts above and ends above. It's 90 because it was 360 over 4. The plus 5 is the shifted up 5, and we're good to go. Now, if they wanted it in radians, instead of doing 360 over 4, you would just do 2 pi over 4, which would be pi over 2. So you'd write the exact same thing, but in radians, you'd put that in place. So you'd put pi over 2 in place of the 90, and you'd have the exact same question, but in radians. Remember, radians are just another way of writing units. Okay, I like feet, inches, meters, just different way of measuring. All right, example 2. A Ferris wheel, 50 feet in diameter, makes 1 revolution every 40 seconds. Hey, 1 revolution every 40 seconds. Might they be giving us the period here? If the center of the wheel is 30 feet above the ground, determine an equation that would model the path of a rider on the Ferris wheel. All right, so let's think about this. We have a Ferris wheel. Yay. And it says the center of the wheel is 30 feet above the ground. So all the way down here is 30 feet. Okay, and hopefully the Ferris wheel is up in the air, because it kind of makes sense. Otherwise, it'd be rolling along the ground, and that wouldn't be a very fun ride. So it's 50 feet in diameter. All right, so that means from here up has to be 25, and from here down, which is not the middle of it at all, has to be 25. I apologize, that picture is pretty crappy. So it says the center of the Ferris wheel is 30 feet above the ground. So if the center of it, which I have is being very oddly placed right here, not the actual center, but it's 30 feet, that means the Ferris wheel, the very bottom portion of it is only 5 feet above the ground. Okay, so it's 5 feet above the ground. So from there, I think we can kind of draw this picture and then hopefully come up with the equation pretty quick. So go all the way down to here, go all the way over. Here is my max, here is my min. So my minimum is going to be down to 5. My max is going to be up 5 plus 25 plus 25 is up to 55. Okay, that means my middle. Now maybe this one isn't so easy for you to find, so maybe, you know, adding 55 plus 5, dividing it by 2, you know, that works, it gives you 30. Or you could just simply say up the 5 and 25, there's the exact middle of it, right? Or down 25 or up 25 from 5. It doesn't really matter how you find the middle is 30, but you can use the formula. 55 plus 5 divided by 2 is 30. From there it says 1 revolution should take every 40 seconds. So that means, okay, I go over here to 40 and say, yep, that's where 40 is. I've determined that that's where it's going to end. Now, let's think about this. Where do you get on the Ferris wheel? Okay, well, if you're crazy, right, you get on it someplace over here or over here, but in most places you get on it right at the bottom. So we're going to start here. And since we're starting below the midline, this is sometimes tough for people to understand. I'm going to be starting below the midline. We have a cosine curve, but more specifically, we have a negative cosine curve. So it's going to start below, it's going to end below. It's a bad picture, I'm sorry, that line kind of goes up. All right, and then right in the middle, which we'll have to call 20 seconds, hopefully that's the middle, it should be at its maximum. Halfway in between again, it would be on the midline, which would be this 30 here. I guess I could draw that. Okay, it'd be right on that midline. So, play connect the dots. And there we have it. There is our graph. So now we need to put an equation to that. Well, in order to make the graph, we kind of had to come up with parts of the equation. So we said the amplitude was how far we were shifting up. So from 30 up to 55 is 25. Okay. This is a negative cosine curve, so when we write cosine, we have to attach a negative in front of the 25. That lets us know that it starts below. We need the frequency, so I'm just going to put an x and remember to come back to that, because we didn't find that. And the shift, how far do we shift this bad boy up or down? Well, the middle of it is at 30, so the whole thing is shifted up 30. So, we need the frequency. To find the frequency, we have to use the period. And we already said what the period was. The period is equal to 40. So the frequency is 360 over 40, which works out to be 9. That's in degrees. If we wanted it in radians, we could totally do 2 pi over 40. Okay, so if we did 2 pi over 40, that would become pi over 20, or you could leave it like that and you would just put that in place. of the 9. Either way, you're good to go. Let's move on to the next one. Okay, so here we have the profits of a nursery modeled by a sinusoid. That's just another way of saying a periodic function, something that's cyclical. So the profit peaking twice each year. The profit reaches a yearly low of 4,000 in January and a high of 14 in April. Determine an equation for their yearly profits. So we're going to graph it over the course of a year and see what it looks like. So we know the low is 4,000. Put that on here. There's 4,000. The high is going to be 14,000. These are profits. And then we have to have months. So we're going to start off with January, April. We need to have again May, June, July. Trying to label June. Okay, so we have January right here, March, April, February, March, April, May, June, July. Okay, let's plot the points that we have thus far. So in January it's the low. We'll start down here. In April it's a high. So we've got to find the pattern that we're having. So January, after January we count 1, 2, 3 months. For April is our high, so we're going to count again. 1, 2, 3 months. That puts us in July for our low. Okay, then we got to count again. So July, then we have August, September, October. Again, we're going to have a high again. That was October, and then we go 3 more again. So October, November, December, and then we start right back off again of January, and it working out. So 1 year's time, that's what we're having going on there. Okay, kind of weird looking, but that's what it is. So we're going to have our middle line right here, plotting our points. Halfway between January and April, it went, if you count it, 1, 2, 3. So we're going to be 1.5 halfway on the line. Again, halfway on the line, halfway, 1.5 over again. We can play connect the dots. So, not the greatest graph I've ever drawn, but all right. So amplitude, frequency, period, and the shift. So we need to find that shift line first. So most of you can look at 14 and 4 and figure it out. If you can't, it's not a big deal. 14,000 plus 4,000 is 18 divided by 2. So we add it up, the 14 plus the 4 divided by 2, that gives us the 9, and it's 9,000. So put that on here as 9,000, that is our shift. From there, you ask yourself, what is the amplitude? What's my distance? All right, and it's from the middle to the peak, or the middle to the low. All right, from 9 to 14 is 5, or from 4 to 9 is 5,000. So we now have our amplitude is 5,000. We said our shift was at 9,000. We just need to know our period so we can find our frequency. The period is the length of one cycle. So how long did it take to complete one cosine curve here? Well, in this case, we started in January, so we went 1, 2, 3, 4, 5, 6. Okay, it took till July, so it took 6 months to do so. All right, so the period is 6. Come on, pick the right button here. So period is 6. So frequency is now going to be 360 over the 6, which gives us 60. So writing the equation, y equals, the amplitude is 5,000. It's a little bit weird. That's a huge number. Cosine, but it was a negative cosine curve, so now we're going to throw that negative sign in front. All right, the frequency was 60, so 60x, and then we are shifting the whole thing up 9,000, so plus 9,000. And there you have it. Again, if they were using 2 pi instead of, they wanted it in radians, if it specifically said radians, it would be the only time I would ever do that. I would totally take and change the 360 to 2 pi over 6, which would become pi over 3. And then I would put that in place here, pi over 3. All right, I want to point this out real quick. If you were looking at this and you thought, hey, if I start right here What curve do I see? Some people see it, some people don't, so I'm going to trace it for you. Just get a brighter color here. So if I were to trace this from there, do you see how there's a sine curve? Sine and cosine are the same curve, it's just they're shifted a little bit left or right. That's just something that you kind of want to notice. They both are the same thing. That's why they can call this a sinusoid, and it still is a cosine. Okay. All right, so let's keep moving on here. Again. Okay, so monthly precipitation in Wyoming can be modeled by a trig function using the average for July and the average for January as a minimum. All right, so using information provided to model the monthly precipitation for Cheyenne, Wyoming. All right, so let's go into this problem. So first off, we have the minimum and the maximum. So go ahead and we'll label the months along the x-axis, and our max is 2.25 and our min is 0.5. So I've gone through and labeled my axes here. I have the x-axis, which technically I should be writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. That's why January to January fits. For those who aren't getting it, so we're starting with January. We can end with January because we're counting the first January as 0. It kind of works out that way. All right, so it's going to start, where are we starting? Let's say the max or the min. Well, I guess we want to model a year, so we're starting with January. So we're going to start right here at our low, and it says its maximum is in July, so that's right here, halfway, and then at the end, it has to end the following January at that same level. All right, in between, halfway, have our nice line right here. So halfway between 0 and 6 is going to be right at 3. Halfway between the 6 and the 12, July and the next January is going to be 9. Play connect the dots. All right. Need to find our amplitude, frequency, and period. So the amplitude is going to be found once we have the shift line. I apologize. So where is the shift? I have 2.25 plus my 0.5. All right. Is that going to be 2.75? So we're going to add those up. Maybe I'll actually write this time. 2.25 plus 0.5 divided by 2 gives us 1.375. That's really weird, but that is the middle. From there, we have to find the amplitude. The amplitude is the distance between the max and the middle, or the min in the middle. So you can just subtract those guys. That works out to be 0.875. You go to your calculator, type it in, and then we need the period. How long does it take? Well, it takes 12 months to complete one cycle. Okay, so that means the frequency is 360 over 12, which is 30. Again, if they wanted it in terms of radians, you'd do 2 pi over 12, which would be pi over 6. So we're going to write our equation and be done. So y equals the amplitude, which is 0.875, times cosine. It's a negative cosine curve, so we throw that negative in front. The frequency is what goes in front of the x, and then the whole thing is shifted up 1.375, and there is your equation. Again, if this was in terms of radians, it'd be 2 pi over 6, which would give us pi over 3. We'd have pi over 3 here. But if it doesn't say, give the answer in degrees. That's it. Don't forget to write your summary and do your practice problems. Thank you.